All right, hi everybody. So the A5 notes cover probability and statistics. We start out here with the definition of relative frequency. So the relative frequency is the frequency of the category divided by the total of all the frequencies. Here in the first example, you're asked to complete the two-way frequency table. The directions to the question tell you that there are 200 students total that were asked the question. In a two-way frequency table, the grand total goes down here in the lower right. Each of the rows and each of the columns should sum to give you the total for that column or that row. But then in the end, all of the totals should add up to give you 200 both ways. And so you want to find a place where you can start on this table. Notice that in the yes column, you know that there's 172 students total that said yes. So you can use subtraction to figure out that 172 take away 154 means 18 students said yes to watching Netflix, but no to watching YouTube. And then working off the information that you're given here, 18 plus 18 gives you 36. So there's 36 total students that said no to watching YouTube overall. And then you can work backwards using subtraction. So 200 take away 36 gives you 164. 200 take away 172 gives you 28. And then 28 take away 18 gives you 10. So you're using addition and subtraction to fill in the table. Notice that you can check your answer by adding up the numbers in the total row. So both along the bottom and down the right-hand side, the numbers should add up to give you that grand total that's in the lower right-hand corner. The next section of notes goes over some important definitions. Joint relative frequency is found by dividing a frequency that's not in the total row or the total column by the grand total. It tells what portion of the grand total has both of two specified characteristics. Marginal relative frequency is found by dividing a row total or column total by the grand total. It tells what portion of the total has a specified characteristic. Conditional relative frequency is found by dividing a frequency that's not in the total row or total column by the total for that row or column. And so it's important to note that in conditional relative frequency, your denominator changes. And then lastly, an association is a numerically significant trend in the data that indicates one or more variables have an impact on the likelihood of the outcome of an event. And so we'll look at an example of that today as well. All right, so in this next example, the two-way frequency table is completely filled out for us. It says that 90 random students at a school were surveyed, so the 90's down here in the grand total row. They were asked to identify their gender and then also to say what their preferred sport was. The first question here on the notes asks us to figure out what's the probability that a student prefers football. And so we'll look at the football column. So there's a total of 25 students overall that said they preferred football. And so this is a marginal relative frequency. So 25 students prefer football out of 90 total students. You can divide that. Frequencies can be given as reduced fractions. So as a reduced fraction, these both divide by 5. You could write it as 5 over 18, or you could write it as a decimal, 0.28, or sometimes you'll see them written as a percentage. So you could write it as 28%. All of these are correct answers to the question. The second question asks, what is the probability that a student is a boy? And then here's the important part, given that the student prefers soccer. Whenever you see something like that, where something is conditionally described as being dependent upon another thing. So here I'm only looking at the soccer column for my total. For the soccer column, there's 30 total respondents that pick soccer. Given that the student prefers soccer, means that my denominator is going to be 30. And it says, what's the probability that of those 30 people, the student is a boy? So this one's going to be 5 out of 30. Remember, you can give it as a reduced fraction, so 1 out of 6, or you could write it as 0.17. The next question is also a conditional relative frequency as well. It says, what is the probability that a girl prefers basketball? So for this one, you're only looking at the girl row to get your total. So 50 total girls answered this survey. They want to know of those 50 girls, how many of them said that they preferred basketball? And so 20 out of 50, again, as a reduced fraction, it would give you 2 over 5, and then you can also write it as a decimal, so 0.4. So even though on C, it doesn't say given that the student is a girl, the way that the question is worded indicates that you're only considering girls when you're looking at your total. So picking the number that goes in the bottom, in the first question it was a 90, in the second question it was a 30, and then in the third question here it was a 50. That's one of the important parts in getting the answer to these questions correct. Question D is a bit of a complicated question. It says, do the results of the survey indicate an association between being a boy or a girl and preferring basketball? And so there's 3 numbers that we have to figure out to answer this question. So the first thing I'm going to do is figure out the probability that a person selected at random prefers basketball. And so for this one, there's 35 people that prefer basketball out of 90 people total. And so doing that division would give you 0.39. Once I have that information, it wants to know if there's an association between being a boy or a girl and preferring basketballs. The next thing I'm going to figure out is what is the probability that a person prefers basketball given that they were a girl. And so out of the 50 girls surveyed, 20 of them preferred basketball. And so 20 out of 50 would give you 0.4 when converted to a decimal. And then I also need to figure out the same, but for a boy. And so what is the probability that a person prefers basketball given that they're a boy? 15 out of 40 gives you 0.38. And so looking at the values for the 3 answers to the questions, they're all super close to one another. And so for this question, we can conclude that no, there's no association. Being a girl or being a boy does not make a person any more or less likely to prefer basketball. All right, moving on to the next part of the notes. So a correlation of a set of data is a measure of the strength of a linear relationship between the variables. And so it says that data can be correlated positively. So you can see here the line would look like it was going up, the line that goes through the points on the scatter plot. Here it can be correlated negatively. So again, a line drawn through the points would look like it was going down. When data has no correlation, it just means that the points are scattered. So it doesn't follow a line up or down. It kind of just looks like a blob. The positive or negative correlation of a set of data can either be strong or weak. So strong negative means that the points are all really close to the line and the line is going in a downward direction. Strong positive means that the points are all really close to the line, but the line is going in an upward direction. Weak negative means that the points are kind of going down, but not as close to the line. And then weak positive is same thing. So the points are kind of following the line, but not really closely. They're a little bit further away from that line that goes through the middle, and they're going in a positive or in an up direction. We can describe whether data would be expected to have either a positive, negative, or no correlation. In A, you would expect that if you study for a test more, your score would go up. And so we would say that these would be correlated positively. On B, these 2 variables have no impact on one another. The height of a person would not have any impact on the number of letters in their name. And so we would say that there would be no correlation. On C, the time you spend practicing shooting a soccer ball and the amount of goals that you score, we would expect that additional practice would result in increased performance. And so we would say that these would be correlated positively. And then lastly, if a product increased in price, we would expect that the number of items that were sold would decrease. And so we would say that these are correlated negatively. All right, the next part of the notes is a big reminder about the different measures of central tendency. The mean is the average, and the mean is defined as being the sum of the data values, so you're going to add them all up, and then you divide by how many there are. The median is the number in the middle when they're arranged in order. The mode is the number that occurs the most times. Standard deviation is a numerical calculation that describes how spread out the data is from the mean. The range is the difference from the highest to the lowest data number in the set. Quartiles divide data into 4 equal parts. And lastly, the interquartile range, or IQR, of a data set, it's a measure of variability, and so you find Q3 minus Q1 gives you the measure of the interquartile range. All of the measures of central tendency are designed to help us analyze data. And so here in this next example, we're given a list of numbers. There are 17 numbers in the list, and we're asked to find the mean, and we're asked to find the median. So to find the mean, you do not need to put the numbers in order. To find the mean, you grab a calculator, you'd add all the numbers in the list up. When I sum all of these numbers up, I get 70. And then to find the mean, I have to take the total sum of all of the numbers, and I divide it by the number of numbers in the list. So here I'm dividing by 17. I'm not told how many decimal places to round to on this one, so I'll just round to 2. So I get 4.12 as my mean when I round that answer. To find the median, which is the second part of this question, you need to start by putting all of the numbers in order. Once the numbers are in order, you're going to count in from the outside until you find the number that's in the center. So 1 and 1, 1 and 1, and then you'll continue. And here, there are 17 numbers in the list, so there is a true center. Your median here is 3. That's the number that's right in the middle. The next question is similar in that you will need to find the median. It wants us to list all the quartiles of the data set. So I'll need to find Q1, Q2, Q3, and then Q4. I don't need to find the minimum. Remember that Q2 is your median and Q4 is your maximum. So I can answer Q4 without putting the numbers in order. The maximum number in this list is the number 8. But in order to find Q1 and Q3, I first have to find Q2, and in order to find the median, I have to start by putting the numbers in order. Once the numbers are in order, I can't find Q1 and Q3 until I find Q2. So to find the median, I'm going to count in from the outside. So 1 and 1, 1 and 1, and so on. This list of numbers coincidentally has 17 numbers in it as well, but an odd number of numbers means that there's a true center, and so your median is 5. Once you have your median, you need to find the middle of the upper half of the data set, and then you need to find the middle of the lower half of the data set. And so I'll do Q1 first. So again, I'm going to count in from the outside. 1 and 1, 1 and 1. Here there are an even number of numbers in the lower half of the data set. To find my Q1, I'll add 3 and 3 up, and I'll divide them by 2. I'm going to average these two numbers. 3 plus 3 is 6, divided by 2 gives me 3. And then I'll do the same thing on the upper half of the data set. So 1 and 1, 1 and 1. Here I'm averaging together 6 and 6, and 6 plus 6 divided by 2 gives me 6. And so here for this question, your answer is all 4 of these numbers because you were asked to find all the quartiles. percentiles. All right, on the next example, you're asked to calculate the mean, median, mode, and range for the two classes and then fill in the chart. So 2 line plots are given to you here. I'll do class A first. So when I add up all of the numbers in the list for class A, I get 91. And when I count the number of X's, there are 26 numbers in the list. Divided and rounded to 1 decimal place, I get 3.5. So my mean for that one is 3.5. To find my median, I don't have to write down a list of the numbers. I can simply count in from the outside. So 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, and so on. The last two numbers remaining in the middle are a 3 and a 4. And so to find the median, I would average those two together. So 3 plus 4 divided by 2 gives me 3.5. To find the mode, I have to look for the number that occurs the most often. And so in this list, the 3 and the 4 are tied. So we say that there are two modes. The number 3 is the mode and the number 4 is the mode. And then lastly, for the range, I need to take the highest number in the list, which is 6, and subtract the least number in the list, which is 1. And so for my range, I get 5. For class B, I can start by finding the mean. So for this one, when I add up all the numbers in the list, I get 95. And when I count the X's, there are 21 X's. And so 95 divided by 21 rounded to 1 decimal place gives me 4.5. For the median for this one, I'm going to count in from each side. So 1 and 1. 1 and 1, and so on. And so for this one, the number that's left over when you count in from either side of the outside is 5. So the median is 5. On this one, the mode is tied between 5 and 6. So we say there are two modes. And then lastly, the range is the highest number in the list, which is 6. Take away the least number in the list, which is 1. So for this one, the range is also 5. The last part of this question asks me to compare the mean, median, and range for class A and class B, and to say which one is greater, or in the case that they're equal, to say that they're both equal. And so I'm going to put markings on the chart to indicate the answer to the question. Comparing my answers, the mean is greater for class B, the median is also greater for class B, and the range for both of them is equal. So those higher numbers that are here on the right-hand side for class B pull both the mean and the median higher. A histogram is a bar graph where the categories are ranges of data values. And so here it says the histogram shows the frequency of the age of different board members in a company. The first thing wants us to answer what age group occurs the most frequently, and so that's the age range with the highest bar. And so 60 to 64 years old would be the age group that occurs the most frequently. The second part of the question asks what age group has a frequency that is equal to the 50 to 54-year-olds. So here's my 50 to 54-year-olds in this first bar. And so the age group that has a frequency that's equal to that would be the next bar right over here, the 55 to 59-year-olds. And we know that because those two bars are the same height. A box and whisker plot is another way that data can be represented. And here a box and whisker plot is given to you. The question asks you to complete the chart, so to pull off the important numbers from the box and whisker plot. Box and whisker plots always contain 5 important points. So the minimum is the least point. So for this graph, the minimum is 70. Q1 is the point that starts the box. And so for this graph, my Q1 is 73. Q2 is my median. And so for this graph, that's 81. Q3 ends the box. And so for this graph, that's 84. And then lastly, Q4 is my maximum. And for this graph, that's the number 87. So those 5 numbers that are color-coded there are the 5 important points that you pull off the graph. Remember that the range is the maximum value minus the minimum value. And so it's the purple minus the yellow here. And so 87 take away 70 gives me 17. And then lastly, to find the interquartile range, your IQR, remember that your IQR is equal to your Q3, take away your Q1. So here on the picture, it's blue minus green. 84 take away 73 gives me 11. Just add a little note to the side there for how you figured out the 17 and 11. All right, a reminder here about 2 different types of data. So numerical data is data that's expressed in numbers rather than in using language or categories. Sometimes numerical data is referred to as quantitative data. Categorical data represents characteristics, and so some examples here are given. A lot of times when we're talking about these 2 types of data, we'll say that numerical data is numbers and categorical data is words, and so that might help you understand the difference between them. Now some practice with probability. The probability of an event occurring is a type of ratio where we compare how many times an outcome can occur compared to all of the possible outcomes. And so a lot of times you'll see probability defined as this, as successes out of total. In the first example, the spinner at the right is divided into 8 equal parts. Find the theoretical probability of landing on the given sections of the spinner. And so for all of these where you see the letter P, that means the probability of. So in the first example, I'm trying to figure out the probability of landing on 8. Looking at the spinner, there's one way that you can succeed in landing on an 8 because there's 1 8 on the spinner. There are 8 total possible outcomes because there are 8 different numbered sections of the spinner. Probability can be left as a fraction, but often it will be converted into a decimal between 0 and 1. So you could write it as 0.125. Remember, you could also write it as a percentage, so you have a 12.5% chance of landing on an 8. The probability of landing on a 5 is the same as the probability of landing on an 8 because there are 1 total successes, so there's 1 way you can land on a 5. 5 out of 8 total outcomes that are possible. And so you might say that you have an equally likely chance of landing on a 5 as you do an 8. The probability of landing on not an even number is the same thing as the probability of landing on an odd number. So here on the picture of this spinner, there are 4 numbers that are not even numbers. Those are the numbers 1, 3, 5, and 7. So there are 4 ways of succeeding of landing on a not even number out of 8 total possible ways. That fraction would reduce to 1/2. And then remember, you can write it as a decimal as well. So you have a 50-50 chance or a 50% chance of landing on not an even number when you spin the spinner. The probability of landing on an even number or an odd number is 100%. All of the numbers here are either even or odd. So you have 8 ways of succeeding over 8 total possible outcomes. And so for this, you could say that it's 1.0. You could also say it's 100% chance. Theoretically, there's nothing that could happen besides it landing on one of these numbers. The probability of landing on less than a 5, there are 4 numbers that are less than 5. Those are the numbers 1, 2, 3, and 4. So you have a 4 out of 8 chance, which would reduce to 1 out of 2, which as a decimal would be 0.5. So again, a 50-50 chance. The probability of landing on a number that's greater than 4, there are also 4 possible ways of that happening. It could be a 5, a 6, a 7, or an 8. So 4 out of 8 possible ways reduces to 1/2, which is 0.5. Notice that in the list, none of the probabilities are negative numbers, and they're all between 0 and 1. Sometimes probabilities get a little bit complicated when you have to think about whether something is being replaced or not. The first example here says you choose a marble at random from a bag that contains 5 red, 8 blue, and 2 white. You replace the marble, and then you choose again. So it's important to note that here replacement is occurring, and it's also important to note that there are 2 events occurring. The probability of 2 events occurring together is the product of their separate probabilities. It's important to start by adding up the total number of marbles that are in the bag. So 5 red plus 8 blue plus 2 white gives you a total of 15 marbles. So for the first part, the probability that if you pull out 2 marbles with replacement, that both of them will be white. For the first pull, you have 2 possible ways of succeeding. There are 2 white marbles in the bag out of 15 total marbles. And then you put the marble back. So in the second event, you still have 2 white marbles and 15 total marbles in the bag. The probability of these 2 events occurring together is the product of their separate probabilities. So 4 out of 225, and if you wanted that written as a decimal, the probability of this event occurring is 0.02 or 2%. In the next example, it wants to know what is the probability of first pulling out a blue marble and then pulling out a red marble. So to start, there are 8 blue marbles out of 15 total. So the probability of the first event occurring is 8 out of 15. The marble is then replaced, so the denominator remains the same. For the second event, there are 5 red marbles, so 5 successes out of 15 total. The probability of those events occurring together is 40 out of 225, which when converted to a decimal and rounded gives you 0.18. And finally, in the last example, the probability of pulling out a white followed by a red, so there's a 2 out of 15 chance, right? 2 white marbles out of the 15 total, and then you put the marble back so the denominator does not change. And then pulling out a red is 5 over 15. And so here, the probability of these events occurring together is the product of their separate probabilities. So 10 out of 225, and then converted into a decimal, it's 0.04. Out of these 3 scenarios, the middle one, blue then red, is the one that's the most likely to happen. All right, the next example feels similar, but there is a small but very important difference. 4 rock songs, 7 rap songs, 2 instrumental songs, and 8 country songs means a total of 21 songs. Suppose you play songs at random, and then this is the important part. If the phone won't play the same song twice. And so the probability of this occurring, the probability of a rap song being followed by a country song, it's important that you note that the phone won't play the same song twice, so replacement is not occurring. The probability that a rap song would first play, there are 7 rap songs out of 21 total songs. And so the probability of that first event occurring is 7 out of 21, but here's where it changes. The probability that the second song will be country, there are 8 country songs, but here the denominator changes. It's not replacement in the sense that you're putting it back in the bag, but because his phone won't play the same song twice, there is no replacement occurring. And so the denominator drops down 1 because there's 1 fewer song overall to pick from. The 8 doesn't drop down though, because picking a rap song first does not affect how many country songs are left over. So these are the probabilities of those 2 events occurring separately. The probability of them occurring together is a product of their separate probabilities. So multiplying these gives me 56 out of 420, and then you would divide those numbers to get the decimal answer to the question. And so here it's 0.13, so there would be a 13% chance of this event occurring. And then lastly, this final example is about cards. You want to remember that a standard deck of cards has 52 cards. There are 4 different suits, and there are 13 different values of each of the cards. 13 times 4 gives you 52. What is the probability of drawing 2 cards in succession without replacement? So make sure you identify that this one's without replacement, and having them both be face cards. And so it's important to note that face cards are the jacks, the queens, and the kings. And so here the probability of having both of those cards be face cards, to start, there are 12 face cards. There are 4 jacks, 4 queens, queens and 4 kings out of a total of 52 cards in the deck. So the probability of having the first card be a face card would be 12 out of 52 without replacement. And assuming that the first event was successful and yielded you a face card means that there would be 11 face cards left over to be successful, and then 51 total cards left over in the deck. So on this problem, both the numerator and the denominator changes. So again, there's no replacement occurring. The probability of these events happening together is 132 out of 2,652. And so again, to find the decimal approximation, you'll divide these, and rounded, it's 0.05. So there's a 5% chance that you could pull out a card and then pull out another card from a standard deck of cards and have both of the two cards that you pull be face cards.